Hey, good evening. It's Vicky Duncalf. It's a Pop Astro Live. It's Tuesday night. It's 8 p.m. And we've just had a fantastic storm out in the Irish Sea on Anglesey. So I am happy. Please start sharing the video. It helps with our algorithms greatly. And in the meanwhile, I shall play the magic video. Now, Pop Astro subscriptions go up by £2 on Saturday. So if you haven't renewed your membership or you are thinking of joining, do it before Saturday for your benefit, but do it after Saturday for our benefit. It's up to you how benevolent you're feeling. And we've got a very important message for some very senior people who would like to tell you to do just that. So share the video while the countdown plays.
When I first started being interested in astronomy, it was just a question of looking up at the night sky, and it is spectacular even if you don't know what you're looking at. But at some point, very quickly, you decide that you want to know more, and the more you know, the more wonderful it gets. SPA has been helping people into astronomy to understand what they're looking at for more than 50 years.
As Brian says, the SPA is a great way to start or accelerate your astronomical adventure. We spoke to our new president, Professor Andrew Coates. Why should people join the SPA?
Well, the SPA is really important to join. It's probably the best society for entry-level astronomers in the UK. And the SPA gives you so many benefits. There's, of course, the magazine. It's great for young stargazers. My colleague Lucy is the chief stargazer.
We have a packed section for the junior stargazer.
Hello, I'm Lucy Green, I'm Chief Stargazer, and it's my role to help you all enjoy the fun of astronomy.
If you want to make new astro friends, our interactive chat show is the ideal place.
Then you just float, and it's like that feeling when you're just floating in a pool.
There are so many reasons to join the SPA. What will yours be?
Strongly recommend, if you want to learn a bit more, you join the SPA or go to the website popastro.com.
Thank you very much. Please obey Brian Cox, for what he says is the truth. So, good evening. Are you lucky enough to have a Pop Astro hamper? I've got one, and I can confirm the corner of the Milky Way flippogram, I don't know whether they're called flippograms, but they should be. It's really sharp when it jabs you in the chops. I've just discovered that. Plug the mug, plug the mug, plug the mug, plug the mug. I've got stars in my eyes and a fidget cube in my plug the mug. You can get fantastic merch from the Pop Astro shop. And you can renew your subscription on the Pop Astro website as well. And also, Robin's fantastic autumn sky guide is up. He goes out on clear nights and very, very diligently. Robin, when are you going to get an OBE for services to astronomy? Oh my God, the amount of effort and hard work Robin puts into the SPA, it really is his labor of love. And from what I've heard, I still don't know whether we need... I'm fairly sure that we need help with the magazine. Robin is still doing it. He's supposed to be enjoying his retirement, and instead he's making masterpiece videos and masterpiece magazines to look after all of us popular astronomers and to keep us entertained and informed. So give Robin a hand, join the society, buy a mug, and edit the magazine for him if possible. Hello, let's see what's happening in the chat room. Bonjour, my astral brother. Monsieur All in Eye. Madeline Dunn, another week. I know, I like to tick them all off. Nearly Christmas, nearly Christmas, nearly the Rhinos, nearly Christmas, nearly the conscience. Hi, Vicky. I am really well. I'm feeling very glowing and very happy at the moment. SPA magazine, less adverts, more astronomy. That is it's a great little slogan. Can we nick that, please? Thank you. Good evening, Ian Baker, the delightful Ian, who I still have to meet, maybe one day. Bob Jessamine, the man with stars for his face. I love that picture. Can you see it? That little profile pic? It's a little starry face. Jedmak, 10 out of 10 for spelling my name correctly tonight. Thank you so much, Jed. Good evening, Vicky and the rest of the gang. That sounds like the Kool and the Gang tribute act. We'll be on stage shortly. Highlight of the month. What's happened? It's not clicking. Oh, my mouse broke today. Don't do it. Highlight of the month. I'm afraid, Ian, I'm going to have to correct you. It's highlight of the buy month when the SPA magazine pops through the door. Thank you. Oh, you all make me feel so loved. It was worth putting my hat on. Do you know, I've been at a space conference online today and yesterday, the UK Space Conference. Wow. And I thought, right, should I do my space tourism? Because I run the Space Tourism Society. And I was like, should I do my video or my space tourism where the space... I'm basically deciding which hat to wear. And I was like, why not wear a real hat? So I have been online introducing myself to I don't know how many delegates today wearing my space tourism hat. They're all sat at home waiting for people to connect on this online conference. It's like chat roulette, and suddenly I'm there with me and Cosmo and my hat. So that's why I'm wearing the hat today. I've actually wore it for my day job today. Do you like my little spacey jumper and my little spacey necklace? None of these are available in the SPA shop, but the fidget cube stuck. This beautiful, highly, exquisitely accurate sundial pendant. Like, you would never guess that could tell the time almost so precisely to the minute. But you shine the sun through it and then you line it up and point it south, and the little light falls directly on the correct time. That is a brilliant little gift for the space lover in your life. It is. Best hat. Love it. Thank you. Oh, thank you, Kiri. Hi, Kiri. Hello, everybody. Thank you, Adrian. Thank you. Thank you so much. Okay. Oumuamua is back. Well, not strictly speaking back. It's back on Pop Astro Live. Yeah, I know it's misleading. I know it's clickbait, but I got to have a bit of fun with you, haven't I? We tonight have got John I Davies, editor and senior researcher at, check out this, the Initiative and Institute for Interstellar Studies. And he's going to be talking about why we should chase this fleeting, very, very, very fast-moving visitor to the solar system. We've got... Can't have him yet. We've got quizzes, brain teasers, the usual pandemonium in the chat room that moves so fast I can't keep my eye on it. Oh, yeah. Now, did anyone see the bright light in the sky last after? I got 2 pictures of it. Yes. Yes. Now, it was a rocket, was it? It was like a fan of white light in the sky, and it was amazing. I mean, millions of people must have thought they were seeing a UFO, which, to be fair, they were. Not everybody knows it was it a Landsat or something? Could you just tell me what it was, please? That would be great. That would be really, really good. We've been doing the show for March, oh my God, is it 18 months now? About 18 months. And it's really, really lovely to see the same people and new people come in and out of the chat room each week. This is a really good look. We're heading into winter. The nights are drawing in. Today is the first day I put out, bang my knee, put on my thermal socks today. And that is a sign that the nights are drawing in and it's time to get cozy with fellow astronomers. That sounds wrong. But what I'm saying is this lovely little community that we've got here is, it's going to be all that we have. So it's going to be so nice just to friend people on Facebook, you know, make friends with these people that you see in the chat room, you know. We can do background check if you want, but I trust most of the people on here. But it's just nice to have regular people and regular commenters and friends in the chat room. And over 18 months, we've all got to know each other really, really well. And a lot of the people who've joined us on Pop Astro Live have overflowed onto my Facebook, and we correspond and communicate. And although we're not really up to seeing each other in person much at the minute, really, are we? I mean, it's I'm still anxious about going out in large crowds and things, and back to the city for large events. So let us keep this tight knit community. and let us keep on forging those friendships. It is a pleasure to have you all along. Thank you so much. Hi, Vicky. Why didn't I? Oh, he forgot his packed lunch. He got halfway there. You idiot, Cosmo. He got halfway there and realised he'd forgotten his packed lunch. Come back, and now it's too late. Or is it? Let's go and speak to John I Davies at the... I feel the same today. It is, I swear. Right, we're going to get John on now in 3, 2, 1. Hello, John.
Hi.
Hello. Hi. How are you?
I'm fine, thank you. You can call us I for IS. It's a lot shorter. You don't need both. Yeah, you don't need both, and that's our web address as well. So that's nice and easy. It's I, digit 4, I, the letter I, and then S. Just those 4. I4IS.org. That's us.
Okay. Wow. I mean, it is
and that
quite
covers both organisations. The complicated. The reasons complicated why there's 2 names. I won't bore you with it. It's all sort of regulatory, boring, sort of tedious, bureaucratic stuff. So let's move on.
If there's one thing everybody knows, if there's one thing every person knows, is we don't do bureaucracy on Pop Astro Live. So, John, it's a pleasure to have you. Tell us who you are and actually what those initials stand for, please.
Well, the Initiative Institute for Interstellar Studies dates back to 2012, and both organisations, Initiative in the UK, Institute in the USA, were properly incorporated in 2014, and we've been around and doing things since 2012. We grew out of the British Interplanetary Society. If you don't know about the British Interplanetary Society, then you should. It's been doing space stuff since 1933. Nobody in the world has been doing space stuff for that long continuously. So the BIS is something for the UK to be proud of. But we grew out of them. We're all still members, but we're specializing in interstellar because we think we can send a probe to the stars in not my lifetime, probably, I'm pretty old, but possibly in your lifetime, Vicky, and maybe in quite a lot of the lifetime of the people that are on your show tonight. But what I want to talk about tonight is a more astronomical thing, because this is an astronomical organization. So let's talk about Oumuamua and Borisov. Now I've got some death by PowerPoint here, but when we tried it last night, there was some question about whether it was going to work or not. In fact, it was looking distinctly dodgy. So if this doesn't work, then you'll just have to make do with a talking head called me. So I'm just going to try a screen share now, and we'll see what happens.
Thank you for that nice comment, Samantha. Right, let's have a look. Okay. Is the screen going to pop up? Oh,
now, does that look like a PowerPoint to you?
It does, yeah. I think you probably just need to go full screen on it.
Right, I'll just go to full screen. Right. Now that means I can't see you anymore in present circumstances. So you're going to have to tell me what people are saying, anyway, just keep me informed and shout at me via Vicky. Ask questions, and we're going to have a bit of an informal Q&A afterwards.
Yeah, sure.
So, here we go. I'm going to gallop through this because this is intended for much longer, and I just want to make it a very quick tour. So, John,
just make it. Can you just make it full screen, like in presenter mode on your thing?
That's what I've got. That's what I've got.
It went full screen last night. We managed to get it to do the full screen PowerPoint. Cosmo, this is your fault.
I'm not seeing anything else but full screen right now. So it looks like we've got the same problems as last night. Well, a variation of the same problem. It seems to be a StreamYard thing. This works fine on Zoom.
Yeah, it does. Yeah.
So let's see. Let me try stopping sharing.
I feel the sweat of every single week. This software gets me at some point.
Yeah, well, unfortunately, you're going to have to pay the Zoom tax, I think. Let me try entire screen.
You know,
Entire screen.
This is more
Allow
expensive.
entire screen,
than-
and then go to full screen. So how's that? What does that look like?
Let's have a look. That's it. We've done it. Stop the
Okay,
sweat.
right.
Let's
Here we
go.
go. Right. So I'm still going to need you, Vicky, to tell me what people are saying. Just interrupt me. Okay, so Oumuamua and Borisov, they turned up within a few months of each other. And one was discovered by a very fancy telescope on Hawaii, the Pan-STARRS telescope, and that was Oumuamua. And a few months later, a guy called Borisov in Romania, an amateur astronomer, like amateur astronomers do, found a comet, Borisov, and both of them are in hyperbolic orbits. In other words, when they go away, they're not coming back. And astronomers can calculate this sort of thing. I'm not an astronomer. Treat me as a sort of half-educated science journalist. I'm really a computer guy, an electronics guy by original trade, but I've always been fascinated by space. In fact, I used to work in the space business, but that's another story. So the question is, what are they? What's an asteroid and what's a comet? Here's some definitions. I won't linger over these, but a comet is gas and solid particles. People have said that dirty snowball is the standard way of describing a comet, and an asteroid is just like a small planet. In fact, big asteroids like Ceres, for example, are I think they're quite classed as dwarf planets now. Anyway, there are spherical ones. Oumuamua very definitely wasn't. We'll move on. So here's some basic facts about Oumuamua. The first thing is it was long. It's about a ratio of length to width of about 5:1, and it's tumbling. And the reason the astronomers knew it was tumbling was because the light curve changed. It's only getting illuminated by the sun. So if the light curve changes, that means that it's reflecting more and less of the sun. And the reason for that is because it's tumbling. And the tumbling is very erratic. It's not following any sort of scheme or anything at all, but it is consistent. The way in which it tumbles, the rate at which it turns end over end and in the other axis as well is absolutely fixed for the whole time it was observed. It's gone out of sight now, telescope-wise. But the weird thing was that it was spotted just after it had reached perihelion, so it was around the sun, and it's now accelerating it's heading out from the sun. Normally, you would expect it to decelerate because everybody knows that an elliptical orbit, the maximum speed is when you're closest to the body you're orbiting. So perihelion for a comet is the point at which it goes fastest, and then it slows up as it leaves the sun. And that was happening with Oumuamua, but not fast enough. It wasn't decelerating fast enough. So there was a net component of acceleration away from the sun. Now, this has been observed with some comets, but it's attributed to outgassing. The outgassing acts like a little rocket, and it's caused by the sun illuminating the dirty snowball, and some of it melts and comes off as outgassing. But that outgassing is visible, and in this case, it was not. And I quote here, "Who said that's funny, and what about?" We'll come back to that. Ask me in the Q&A. Who was an astronomer that said that's funny, and and here's a clue, what was she talking about? Because astronomy is still to a large extent male dominated, but
it sure is so male dominated. We need more ladies in astro.
You definitely do. You definitely do. We've got quite a few women in I4IS actually, but that again, that's another story. So Borisov is just a comet. It happens to be from another solar system, but everything else about it is, you know, a completely normal comet, very average, sort of boring comet, really. So what are the theories about Oumuamua? There's a paper, a very comprehensive paper, and I've forgotten her first name, Bannister. She was at the time at Queen's Belfast. She was an astronomer at Queen's Belfast. I think she's moved on now, but she was the lead author of this paper. And this was the paper that really did the initial analysis on Oumuamua. And they came to the conclusion that it was a low activity comet. But low activity comets, generally speaking, will have visible outgassing, and it didn't. So that's it's the astronomer's best explanation, the least surprising explanation for it. But it was still a pretty weird comet. It might be a thin reflective sheet, so that it's possibly being greatly influenced by solar radiation pressure. And Bjorn Loeb, Loeb is Avi Loeb, who was until last year head of astronomy at Harvard University, so a very respectable guy. And he's come out with some very strange theories about Oumuamua. But you know, who am I to tell him that he's wrong? Most astronomers think he's wrong, but you know, Arthur C. Clarke's second law, if anybody remembers that. Anyway, distinguished but elderly scientist is the thing that comes. There was an idea that a couple of guys, Seligman and Laughlin, they were both at Yale. I can't remember. I think it's Laughlin that's moved on. But again, they had a weird explanation that it was molecular hydrogen in an iceberg. In other words, it was very, very cold frozen hydrogen. There seems to be some doubt about that. And here's what makes astronomers very, very worried about saying anything radical about objects, and that is what I call the little green men factor. So there's the woman I was talking about, Jocelyn Bell Burnell. Everybody heard about her, Dame Jocelyn Bell Burnell.
So good.
Yeah, have you heard her speak? She's a brilliant speaker. So
she has, yeah.
She's got a rather fine Northern Irish accent. I'm saying it all wrong. I'm sure of it.
Oh, do you know what? I don't have many claims to fame, but a couple of years ago, I video blogged at the inauguration of the Square Kilometre Array located at Jodrell Bank, and Jocelyn was there, and they presented her. Oh, I don't know whether I can find the picture of it, but they presented her with this a key, a big metal key. With the shaft of the key was 21-ish centimeters long, and it had the detection of the pulsar along the shaft of the key, and it was made from the plating of the Mark I dish.
Oh, right. Oh, yeah. The dear old Mark I. Yeah, I remember it. I was a wee kid when it was first built, and my dad took us all as a family to go and have a look at it. And I think that does a lot to do with my interest in space.
You know what? Dads should all take their kids to Jodrell Bank, because it seems just to be something that triggers the space love.
Yeah.
Pivotal moment for so many of us.
Yeah. Anyway, I'll tell you about Geraint Evans and the Daily Express if anybody's interested. But they worry that the popular press will say, "Oh, little green men, you know, wacky scientists," and I sort of don't blame them. But Jocelyn Bell Burnell's not worried about that. So that's a new theory. That's the molecular hydrogen ice, and there's a couple of slides about that, but I'll skip through those. They're slightly less plausible now. So why do we need to visit it? We suspect, now I'm putting myself amongst the astronomical community here, which is a bit cheeky, but the Large Synoptic Survey Telescope in 2022 comes online then. It's predicted to discover an order of one stellar object per year. And some of my colleagues in IFRS have done some research on that and come out with a more detailed paper. So if you look for a paper by his name's gone out of my head. He's got a slightly strange American name. We've got several Americans in fact, the initiative is an American organization. That's our sister organization. Yeah, so some of our guys are doing research on the likelihood of interstellar objects, because we're very interested in things from outside the solar system. We'd love to go there or send probes there, more realistically. But if we can have a look at some interstellar objects as they come and visit us, then it's going to tell us a lot about how the rest of the galaxy and the universe. The problem, of course, is that we've only had one instance of an interstellar comet. We've only had one instance of an interstellar, maybe asteroid, maybe comet, maybe something else. Big mystery. So lots of comets, ISOs, we call them, interstellar objects. More cometary ones won't tell us much about one eye. That's how one of my American colleagues refers to Oumuamua, because it's much quicker. Oumuamua was a bit of a tongue twister, but one eye means the first interstellar object, which it was, and
what a great catalogue number there.
Just calls it one eye. So, so here's some papers that some of our people did. Andreas Hines, our exec director and technical lead. Oh, there's Marshall Eubanks. He's TM, Eubanks TM. He's an ex-astronomer from the US Naval Observatory, and he's done work at Caltech as well. Adam Hibbard's a UK guy. He's done a lot of work on missions to Oumuamua, and they are certainly feasible. You need a big rocket, you need a lot of delta V, you need a lot of oomph to get to it, but they are certainly feasible. And there are missions that could take that start in 5 years' time, 10 years' time, and overtake it around about 2040 or 2050. So
right, really, so they can actually catch up with it. I mean, it's going at how fast is it
catch up
going?
with it? Yes, yes.
I'm really
rendezvousing it with is a bit harder, and there's some astrodynamics associated with that, which you can some of you can probably imagine, and I know a bit about, but I'm not really an expert. I'm a sort of journalist really in this whole area. So there's a whole series of papers by our guys about that. Light sails are very interesting, and light sails are our best hope for an interstellar probe at the moment. But that's the light sail equation, and I can come back to that if people are interested. But I'm mainly here about Oumuamua. So as soon as we heard about Oumuamua, the team got together and started working on a paper on how to intercept it, a plan to intercept it, and that was published originally way back in 2017. If you look at our free magazine Principium, it's on the website and you can subscribe to it. It's out every quarter. There's a good piece there about how Adam developed the software to figure out how to overtake. Marshall Eubanks, I told you about. He's ex-Jet Propulsion Laboratory at Caltech. He's ex-US Naval Observatory. Andreas Hein, Dr. Andreas Hein, he's now a professor at the University of Luxembourg. He's our main technical lead, but we've got lots of people in UK, USA, in Andreas's case, France and Germany, Italy. So how do we get to it? We can use a heavy launcher. And use gravity assist, like all the outer solar system probes have done, by slingshotting around Earth, Mars, Venus, and in particular Jupiter, of course. You can lurk at Lagrange 2, if you know about the Lagrange points, and there's an ESA mission going up in 2027, Comet Interceptor, that will lurk at L2 and wait for a comet, and that's a possibility for intercepting a future interstellar object. Or we can use laser push, which is the best candidate for an interstellar mission, and you really can get some hell of a velocity by using laser push, but it's
I've
very
never heard,
demanding.
never
Very
heard of
demanding
laser
technology.
push. What's laser
Okay,
push?
so
Give us a quick.
yeah, I think I'm going to stop at that point. I've probably
Yeah.
said enough. So
I think our minds are collectively boggled.
yeah, okay.
What's laser push, John?
Let me just do a quick. I don't know if this is going to work. That's us. If you can see it,
Oh, yeah.
that's our two logos,
Great.
and that's all our links. And I could send you a PDF copy of this if anybody's interested. Just email me. info@ifrias.org will make its way to me eventually. You don't need my personal email address.
Great stuff,
Right,
John. Thank you very much.
Let me
Thank you.
stop screen. There we go.
Jim is asking, so we'll ask a couple of questions, and I'm just going to go over, because Cosmo's getting impatient. He needs to do his bit. Then we'll come back for an open Q&A. In fact, we'll answer your questions in the next section, if that's all right, John.
Yeah.
Thank you so much for the talk. Right, we're going to put you in the corner for a couple of minutes. Cosmo's going to sing and dance and get thrown to the other side of the room, and we'll be back shortly. Okay.
Okay.
Love a bit of Oumuamua, scout from afar. Traveling at various amounts of miles per hour. I've just been Googling how fast it's traveling. Various websites say 70,000 miles an hour. Another says nearly 60,000 miles an hour. And the NASA website says 196,000 miles per hour. That's on the NASA website. So I guess it's they've struggled to get the radar gun on it, the laser gun on it, and detect its speed. Right, let's get my banner up. I like my banner. There we go. Okay. Everybody in the chat room, gonna have some games with confusing rules. Okay. Cosmo, your time will come shortly. Okay. Best of 3. What space songs are these lyrics from? Now, in this one, you answer as quick as you can for Everlasting Glory. In Cosmo's game, you don't answer as quick as you can. Otherwise, he bites my face in the night. So, what space songs are these lyrics from? In other words, hold my hand. In other words, darling, kiss me. Who's going to be the first to answer it in the chat room? In other words, hold my hand. In other words, darling, kiss me. Can anybody guess this? What do you reckon, Cosmo? One day, I'm sure his head will become separated. Have you ever done that to a soft toy? I've got a cuddly panda and I've hugged it so hard its arms have gone just limp. In other words, hold my hand. Yay, Ray. Oh, Ray. I've still not answered your email, but you have got the Frank Sinatra question correct. So that's 1-0 to Ray Ward. 1-0, 1-0. Keith Quigg, Kevin, hang on, God, now the answers are coming in now. Adrian Bateman, Kevin Quigg. I'm not familiar with your name. If you are a new viewer, please do come back next week. Cosmo will give you a big kiss for now, though. Fly me to the moon, says Gwyneth. Samantha Seal, yes, you all got it correct. Adrian Bateman needs to do his classics homework, but the first answer on my screen was Ray Ward. Well done. You have won a signed Frank Sinatra hologram. It's a beautiful thing. Okay, next one. Song 2. It's lonely out in space on such a timeless flight. It's lonely out in space on such an itchy, sweaty headband. It's lonely out in space on such a timeless flight. Oh, just have a nice scratch under my head while you just figure out what the answer is. What do you reckon, Cosmo? You know what song it is, don't you? Fly me to the moon. Moon me. It was actually moon me to the fly, not fly me to the moon. Doe. Oh dear. It wasn't that, Adrian. Ian Baker has got it correct. Well done. It was Rocket Man. I don't know the lyrics. Well done, Ian. I know you're a music man, Ian, with your monstrously sized guitar collection. Lol, what is that? What is this? If you're just joining us for the first time, it's a space chat show with the cuddly stuffed sloth as the headlining guest. Meme Land Farms. Okay, thank you very much. And Kevin Quigg, you also got it correct. But Ian Baker is the Rocket Man tonight. Okay. Should we do Cosmo's little thing as well? I'm going to do Cosmo now. Where does that live? So many buttons to press. He lives down here. Okay. Cosmo's been on a flight, but where has he been? Can you guess? First, you've got to deal with Cosmo's song. He's been flying around the solar system, or maybe a bit further. But to the casual observer, he's a mithering, pestering sloth. Where have you been to this week, Cosmo? Cosmo, where have you been? 3 clues. Only answer after the clues. Cosmo over and out. They call him Cosmo, Cosmo. They say he's frightening because he is biting my face in the night. If you answer this incorrect too soon. Okay, so this is a slightly different game that we play with Cosmo. Now, he is going to, I am going to read out 3 clues. Where has Cosmo been? And please just let's get all the 3 clues out of the way before you answer, because it's a brain teaser. And if it pops up on the screen, then where was the fun in that? Okay, here we go. Cosmo, it's been a long way. Oh, I think he's getting a bit grubby. I'm sure he's getting grubby. Oh, do you know what? I do Kim Kardashian makeup tutorial contouring. It's actually just very cleverly concealed brown smudges on my face. And I keep hugging him and I can see like a brown tinge to his face. And that's no more cuddling for Cosmo, or at least just kind of at arm's length, like you're hugging a relative with bad breath. Right. Okay. Cosmo is sat on top of something. No, that's not right. He's on something very thin and dark grey, barely visible at all. There are 9 of them. And the 2 outer ones, Cosmo, you've not written these clues down very well. Mucky face or not, my splendid little sloth. They are very thin and dark grey. There are 9 of them. And there are 2 outer ones. The innermost one is the innermost one of the outermost ones. It's reddish. Terrible clue writing, Cosmo. Pasted off Wikipedia. Very thin and dark grey. There are 9 of them. And there are 2 outer ones, of which the innermost one is reddish. Oh, right, go. Where's he been? Where have you been, Cosmo? It was cold and he got little piles on his bum because it was so cold. Don't worry, we've had them lasered off. It was so cold. Right, who's going to be the... Don't hurt Cosmo. Saturn's rings. I'm afraid, Ray Ward, you are wrong. It's a bit cryptic this week, isn't it, Cosmo? Do you remember last week we actually beat the popular astronomers? I can't remember where it was. Where did you go last week? Oh, a moon. Tethys. The Atacama Array. I like your thinking, Jim, but wrong. Jupiter's rings, wrong. Keep on going. Trojan asteroids. No, he's had them lasered, I said. There are 9 of them. They're very thin and dark grey. The 2 outer ones, I've written this wrong. And there are 2 outer ones, of which the innermost one of the outermost ones is reddish. Are you ready? Cosmo countdown. 5, 1, 3, 2, 4. Now, you know I've got the name of this planet muddled up a couple of times, but basically, as I was writing the clues down, I thought, I can't say where he's been. It's just, I get it wrong every... Yes, Bob got it right. It's going to save me from saying it. Getting the inflection on the syllables wrong and making a fool of myself. Oh, Astromanian. Hi, Astromanian. The pillars. No, very good idea. I like your thinking, though. I like your thinking. He has been to there. And I'm not going to say it because I embarrass myself every time. The planet really... Look, I work in marketing. That planet needs a rebrand. George, that's the one. We prefer to call him George. Thank you. Yeah, crazy dark ring system, almost invisible, scarcely there at all. I don't know how you managed to find them, Cosmo. Okay, we have got our guest back, John from the... It's too much of a bigger name for me to remember, so we're just going to put him back on. Hi, John.
Right, I'm hoping your chat works, because I've just put what you should call us in future.
I for
I said earlier, I for IS. Just call us I for IS. And that nice and easy, because it's easy to say, and you just stick .org on the back, and that's us. It's so easy.
Now, I'm having a look at your website, and it's a very expansive, very exciting website.
Oh, well, tell me what you like, or tell me what you don't like.
Oh, well, okay. Well, I do actually critique websites for a living, so we won't go into that. But working towards... No, it looks great.
Give me some free consultancy. I'd be very, very pleased to have it.
Working towards the achievement of interstellar flight through knowledge to the stars, starships in our lifetime. That is the headline on the website. What does that mean?
It means the lifetime of people younger than me, really. Let's look at the two main ways you could send a probe to the stars. One is a fusion rocket, which is just a rocket like any other, except you use nuclear fusion, so it goes a hell of a lot faster. You get a lot more energy out of a fusion reaction, but that's quite hard to do, and it requires quite a big spacecraft and some very fancy fuel that's rather hard to come by. So people working on it, a couple of guys, Canadian and American, Michel Lamontagne and Robert Freeland, just about wrapped up a study for a spacecraft to do that. But 25,000 tons assembled in Earth orbit, a big job, quite a long way away. However, a guy called Phil Lubin, Professor Philip Lubin, University of California, Santa Barbara, pointed out, based on the ideas of a guy ages ago, long dead now, sadly, Robert Forward, who pointed out that if you could get enough radiation on a very thin reflective sail, then you could accelerate a probe to quite high speeds. And people have been talking about using solar sails that way, and you can to some extent, but the amount of energy you can get on a sail from the sun, just pure photons, is rather limited. So what Lubin pointed out, and it had been thought of before, but he did the seminal paper that got things really rolling in this direction, was that you need a big laser bank, and you can get energies out of lasers that were absolutely not even remotely thought of 10 and 20 years ago. This is still a big challenge. But the nice thing about doing it with a very light sailcraft, as it's called, maybe a few grams, maybe a kilogram, something like that. The nice thing about that is that your spacecraft is relatively cheap. The expensive thing is the laser bank, and therefore you can send thousands, tens of thousands, hundreds of thousands. The scaling in terms of number of probes is absolutely staggering, and in fact, the guy who's running Breakthrough Starshot, which is the American outfit that got $100 million of a tech millionaires, billionaires money to do studies on this, says that the bigger challenge is actually, it's not getting the probe to the nearest star. It's getting the information back from that probe, particularly if you're using a tiny one. Which you have to do if you want to get the speeds that you need to achieve. Now, the baseline model is 20% of the speed of light. Simple arithmetic tells you that that's 20 years to the nearest star, 4 light years away. Now, if we can achieve that, and we can achieve it with thousands of probes, then the real big challenge is getting the information back, because it only weighs a few grams, or maybe a kilogram at the most. And it's a long way. and the inverse square law is not your friend. So there's some hell of a technical challenges, but it is very definitely possible. It is not ruled out by any means. So that's the favourite at the moment.
So much new technology there, so I guarantee none of us have probably ever heard of. Jim is asking, how long will it take to catch up to
One Eye?
One Eye.
He's using Robert Kennedy's favourite name for it, One Eye. Yeah. Robert Kennedy's the president of I4IS US, the institute. He just calls it One Eye. How long? A mission of if we'd had a mission in about 2019, which of course was too soon, but if we had a mission in 2019, it would have intercepted in the early 2030s. We're now talking about an intercept in the 2040s, possibly the 2050s. So it's comparatively long time, and we're talking here about completely conventional rockets. We're talking about SpaceX Falcon Heavy, the new NASA Space Launch System. So we're talking about big boosters, but certainly ones that already exist. And the SpaceX so-called Starship, even bigger booster than the Falcon Heavy, would probably be able to do it rather quicker. Or a spacecraft launched through that vehicle would be able to do it rather quicker. But yeah, it's a mission of the same sort of length, or a bit longer length than New Horizons to Pluto and beyond. And I guess you're all familiar with that. And remember that the Voyagers are still going, they're still operating, they're still signaling back to us, and it's more than 40 years since they were launched. So we can do that sort of thing. Long distance missions and long duration missions are very feasible, even with the ancient technology of the Voyagers. So yeah, we can do it. And we don't need any fancy laser power or fusion power to do it. We can use conventional rockets.
That's amazing. What an amazing game of.
So why is it? Yeah, Gwyneth. I won't try and pronounce her second name. I'm terrible at anything other than plain English names. So Gwyneth says, why is Oumuamua traveling so quickly, which is just an inert chunk of something? Well, it's just traveling quickly for the same reason that long period comets do. You think about long period comets, the ones that come from the outer fringes of the Oort cloud, which is the very distant fringes of the solar system, only just within the sun's gravitational field, before the next star takes over, and you'd fall towards that instead. So those very, very highly elliptical orbits, as I said earlier, the maximum speed of those very highly eccentric comets is at perihelion, the closest approach to the sun. And you've got to, the useful thing to think about here is that there's one of Kepler's laws that any orbiting body sweeps out equal areas in equal time intervals. So if you think about radii coming out of the sun and pointing at the ellipse that is the orbit of the comet, where it's at aphelion, furthest away, you don't need very much area you don't need very much of an angle to have a very large area. But close to the sun, you need a great deal of angle to have that same area. So and that's just a sort of rule of thumb, really, but it's mathematical. And it's just that things in orbits like that, they go very, very fast at perihelion. And if a satellite in an elliptical orbit around the Earth has the same characteristic, that perigee is the fastest and apogee is the slowest.
Well, there you go. Right. Okay.
The classic example is a geostationary transfer orbit, which is how you book most of your telecom satellites. So you fire them into an elliptical orbit, and then when you're at apogee, the highest, the furthest point from the Earth, you fire a kick motor to circularize the orbit. So that initial orbit, that geostationary transfer orbit, involves a high velocity as you swing close to the Earth, and then slower and slower as you go away from it, reaching the minimum velocity at perigee, and then you fall back towards the Earth. And you can just do it intuitively with gravity. You know, as you get closer and closer to the Earth, you go faster and faster, and then you whip round it and you go shooting back out again. And as you go away from the Earth, you go slower and slower and slower. So that's how that sort of thing works. That's just basic astrodynamics. Even I can understand that, and I'm just a dumb retired telecoms guy.
Don't put yourself down, John. Thank you for this delightful information. Would the probes form a chain to send the info back?
Yeah, that's a very good question, because some of the guys who are working on this are actually working on that very idea.
Cool.
The tricky thing about that, of course, is that it means that every one of the probes has to have a receiver and a transmitter. So it's going to have a receiver to pick up the signal from the one in front of it, and then a transmitter to signal to the next one in the chain. But of course, if you're doing it in a chain, then you don't need anything like as much power. So there's a swings and roundabouts thing there to be worked out. There's a lot of debate at the moment as to whether you should do it that way, or simply send a whole cloud of probes and then get them to all transmit at the same time in sync. If you've seen things like the Atacama Large Array or the Square Kilometre Array that you were talking about, you can do a great deal if you can get synchronized signals from lots and lots of receivers. And you can do the same with transmitters. If you can get the transmitters in sync, then you can receive the signal from lots and lots of probes. But that's quite challenging too. There are no easy things. Pete Warden, who's the guy who runs Breakthrough Starship, he's ex leader of NASA Ames Laboratory in California before he retired, and he says that the biggest challenge is the signal. He's getting the signal back. Not getting the damn things there. That's very, very hard, but getting the signal back is even harder. And that's my sort of subject area. That was my subject area, although not with satellites. So I'm really interested in that.
Wow.
Good question.
Yeah, let's have a look. How about using ion engines?
Ion engines are very efficient, but they're not very powerful. You can only do things very slowly with an ion engine. They have a very high specific impulse. That's the measure of efficiency of a rocket. You know how much oomph you get for the minimum amount of fuel. Because of course ion engines don't really use fuel. They use a propellant, but it's propelled by an electric field, because you have propellant that is ionized. In other words, it's got an electric charge, so you can accelerate it through an electric field. There's an intermediate technology called let me get this right. This is even worse than Institute and Initiative for Interstellar Studies. It's variable specific impulse plasma rocket. Can't remember how it goes. Vasimir, anyway. They're trying to build things that are intermediate between a conventional chemical rocket and an ion engine, but it's not. It's still very, very new technology. You might be able to do things with that, but it's not thought to be powerful enough. You need a fusion engine. If you're going to use a rocket to get to the stars in any reasonable time, you need something like a fusion engine. Or you can use antimatter. First, catch your antimatter. Antimatter is rather hard to catch, to create.
Oh yeah, right.
That's John Morrell said that Kepler's laws only apply to closed orbits, not hyperbolic or parabolic ones. That is dead correct. And you probably know more about it than I do, John. The point I was making was that in a very, very highly eccentric orbit, an almost hyperbolic orbit, like very long period comets, Kepler's law very much does apply. And then the marginal difference between that and an interstellar object is sort of trivial. In fact, Kepler's law does actually apply to some from some points of view to an interstellar object, because of course then eventually the object is going to run into the gravitational field of somewhere else. So the hyperbola will be terminated, or will become a completely different hyperbola. It's quite complicated.
Hyperbolic hyperbole.
Hyperbola. Yeah, a parabola is an intermediate case between an elliptical orbit and a hyperbolic orbit. I'm dredging up my old school maths now.
Well done, John. John, you're an absolute superstar. Thank you very much. We're coming to the end of the show now. We're running at an hour long now. Thank you so much for appearing on the show. Could you just tell us how to get involved with the IIIA4?
Yeah. Remember the i4is.org. So i4is.org. Go to our website. Have a look. Have a look at Principium. I'm doing a sales job for that because I'm the editor of it. But take a look at what our deep technical guys do. Take a look at all sorts of stuff. Think about becoming a member. That's how you can support us. We're an all-volunteer organisation. We've got professionals working for us, but it's on their own time, not. So, yeah. Link here. Yeah, i4is.org. Yes. Yeah, that's the one. But, how big is Oumuamua? I think it's a few hundred meters long and a few tens of meters wide. That's the size. Yeah. Okay. Well, thanks to everybody for the questions.
Yeah.
And that was fun.
It always is, John. Thank you. And I love the fact that you went so in depth, because we do have quite a well-educated audience here. And this is what the SPA is all about. We have information for astronomers and space lovers of all levels. So if you're just beginning your astronomy or space adventure, the SPA is there to accompany you. We've got so many different sectors and ways that you can get involved with the society, in the magazine and the meetings that we have and the outreach that we do, this chat show as well, Cosmo's effects. So if you want to join the society, it's going up by £2 on Saturday. Please do join us. You'll get the magazine every 2 months. The website is available for everybody to access. Robin's autumn sky video is up, because what I tend to find, and I'm sure we all do with the weather here in the United Kingdom, you have so much cloud and then the moon's out, and then by the time you get to actually have a clear night, the whole sky has moved around like somebody moving the furniture when you've been out to play mind games on you. And Robin's video will help refresh your knowledge where the stars and the planets and the other celestial bodies are this month. And so when you go out, you're not suddenly amazed by the fact that, oh my God, there's Orion. Have you seen Orion yet this year, John?
Not me, no. I watch the ISS all the time, the International Space Station. I've got an app on my phone, and every time that goes over and I see it, if the sky's clear enough, it lifts my heart. It's we need the ISS to keep going. Tell NASA and the rest of them they've got to keep it going. It's
I was at a Space Expo online today, and I spoke to a space company. I can't remember the name of them, but they are sending a mussel experiment up into space. They're sending mussel cultures up that will be flexing, and it's part of the Liverpool University experiment to study aging on mussels. So that was pretty cool to speak to people doing that. We love the ISS. Great. And thank you. Anna said, I have yet to see Orion this year. Always feel better when he's back. Yeah, but I equate Orion with cold feet. He's a cold, icy devil. Orion is.
Only here.
Sonia's not on tonight. We've had Sonia. Yeah, Sonia and Eleni are going to be dipping in and out of the show as and when from now on, Jed. But we'll let you know when they are going to be back. They are both going to be VIP guests on a slightly reduced schedule because they're doing other things. Maybe Sonia might come on next week. We have missed her. The problem with the ISS is metal fatigue in the Russian section, so they want to deorbit it. Did you know that, John? John?
No, I didn't. No, and I'm sure that with a few $1 million or euros, we could replace the Russian section. And
that is so true. Right, it's 9 o'clock. We've done an hour, John. Thank you so very much.
Okay.
Please share the video, join the SPA, watch Robin's video,
Okay.
join the I4IS as well. Have a look at the website, and thank you to everybody who's contributed. We've got to launch Cosmo. Where's he gone? Cosmo, off on your journey into the sky at night. Off he goes. He's gonna catch up with Oumuamua and send us a great report back, and he's going to find out what that weirdo thing flying through the solar system so quickly actually is. What do they think it's actually a chunk of rock from ejected from another planet or moon from another system?
That seems to be the best explanation, yeah, but it behaves very strangely. And Avi Loeb, very respectable astronomer, has different ideas. Look him up.
What was that name again? Sorry.
Loeb. That's his second name, and it's Abraham, but shortened to Avi. He's Israeli originally, but he's in the USA, and he's a prof at Harvard. So yeah.
Thank you, everybody.
Interesting view.
Yeah, John, we'll have you on. We'll have you back on in a couple of months, please. It's been an absolute pleasure, and we'll pick a new subject.
Yeah.
Okay.
Okay.